Hello, happy people of the internet, and welcome back. Thank you for joining me today. In today's video, we're going to be looking at another Wish.com purchase. Today's purchase is the Mini Pen multimeter. This gets, it's a generic multimeter which gets reboxed by various companies and sold under their brand names. This is the KKMoon branded one, so it's got the KKM100 model number, but it comes under all the usual names that one would expect. So let's have a look what's going on the inside. So we've got our instructions, which are written in absolutely tiny lettering, but nonetheless I think it hopefully be fairly obvious what it does. There's the pen itself. So the idea is that you've got your one, instead of having multimeter leads, you've got your one probe in the pen, and then you plug your other probe into the rear of the pen, and you can then probe around on whatever you're working on and measure. Okay. So let's get that set up. Let's stick that in the back. Okay. Okay, so I was going to go through some of the basic functions. It's long press for on. It starts off in an auto mode, which is a very interesting mode because depending on various criteria, if you read in the manual, it's got all the specifics. It will kind of auto-detect what you are trying to measure, be it resistance or voltage or capacitance. And it will automatically switch to the correct mode. So yeah, we'll test that out and see how that works. You can also carry on pressing the on button, and it will cycle through the actual modes. So there we've got DC voltage, AC voltage, capacitance, diode or continuity testing, temperature. That's room temperature. The temperature sensor is inside the unit. It is not the temperature of the tip, which would have been very nice, but unfortunately it isn't. Yeah, so you can see they're holding the tip doesn't change, the temperature doesn't go up. So yeah, that's room temperature. It's got it in Celsius and it's got it in Fahrenheit as well. It measures frequency, I think from 0 up to, depends on what you read on the internet. It's got different specifications to the manual. So it's either 10 or 50 megahertz, but we will test that out and see what it's capable of. So the only thing that I'm not seeing in the menu is resistance, which is quite interesting. So resistance seems to only be available in the auto mode. It's got this light here, which you would think would be used for using this as a logic analyzer, but it doesn't have that feature, and that light is actually for the LED changes color when you're measuring the phases of three-phase power, which is in a separate menu. So EF is electric field. So here if you bring the tip of the probe close to a wire carrying current, it will give a tone and let you know. So that's kind of useful for tracking wires in the walls. But having played around with it, it only really picks it up when it's very close. So I can kind of pick up current in a switch, but if I look and probe around the wall around the switch, it won't pick anything up. This mode is, this is live. This you just poke around AC, and it will tell you if anything is live. And then you've got your three-phase. So you pretty much just hold the tip near the wire, and then it goes phase A, B, and C, and then it will give you a symbolic indication of the electrical phase. So if we go back to auto, and then up front, if you give the one button a long hold, it's got a working light in. It's not super bright, but it is, I think it is really nice and handy, and I think it's quite a neat feature for working in less than ideal areas where you don't have perfect lighting. Another long hold switches that off. And then of course you've got your hold function, which will, as per normal multimeter, will take a reading and hold it, and not go back to zero. And then you can switch that off again. It's powered by a single AAA. Here you can see KKMoon. What does it say on the side? It's got the ranges for the auto. And so here for frequency it says up to 10 megahertz. But we'll test that out and see how accurate that is. Okay, so I'm going to just remove the, if I can actually, just get the covers off the probes, and then I'm going to just looking what I have available around here. So that's going there. Well, we'll have to see how we do it. So I want to bring in a known good multimeter, and then compare the readings for various different. Well, we're going to take various different measurements using the 2 meters and compare them. Okay, so let us start off with some basics, some DC voltage. So I've got my bench top power supply over here set to 16 volts. So if we switch that on and I bring in the leads, so I'm going to hook one over there. Okay, so we can get an indication of how quickly it picks up. Okay, now that's interesting. So it hasn't detected it as voltage. It's detected it as it's gone into resistance mode. That's a bit disappointing. Okay, so let's disconnect that, force it into DC. And we are not getting anything. Okay, well maybe it is because my bench top power supply wasn't on properly. 15.93. Okay, I'm going to go back into auto. That is user error. Auto. There we go. 15.93. Okay. I'm going to bring in my Fluke. Voltage DC. So keep this visible. And we want a negative here and a positive there. And Fluke says 16 volts on the dot. 15.93 versus 16. It's not brilliant, but this did only cost £15. 15.99 versus 15.93. That's not bad. Okay, let's see if I cycle the voltage, if it can. How am I going to do this? How am I going to do this? I need you hooked on and you to stay connected. No. Where's the hook? There we go. No. No. You're really being temperamental. Okay, where is it not touching? Positive. How am I going to do this? There we go. Okay. Okay, so we can see both those. If I go to voltage and drop it, 15, 14, 16, 17, 18 is going up, but I'm turning down, which is very interesting. 12, 11. So they're both pretty much instant. That's pretty good. In fact, the pen is actually ever so slightly faster than the Fluke. Okay, let's see. 16, 8, 7.95. So it's good. I mean, it's close. Good enough for a hobbyist. Okay. So that is DC voltage. So let's kill that. Should both zero out. We can switch you off. Okay, let's have a look at AC voltage. Okay, I'm just going to put these into. Okay, and let's see if we can get you into here. I don't know if this is going to work. Okay, 247.7 to 47.8 volts. That is surprisingly high. There's almost 250 volts AC coming in. Okay, let's see. So 247.5, let's say. Okay, let's see what Fluke says, if I can get it in there. I don't think I'm going to be able to. Don't think that's making contact. Let's see. Nope. I will have to get different multimeter leads. Okay, let me just grab some different leads. I would have liked to keep the Fluke on its own leads, but nonetheless. Okay, so let's get you down there and down here. 250. Okay, and I should have left this on hold. Oh, so let me put you on hold. So you hold. Okay, let's pull you out. Okay, toss the leads over here. Put you on hold. Down you go. Down you go. Oh. 248. So that is 248 versus 250. We can hold that. So not bad. Good enough for the hobbyist. Okay. get that off. While we're here, let us try the EF and see. Oh, that will only flow. That will only work if this is actually plugged into something. So that won't work, but we can check the live. So if I stick this down, let me see here, if I stick this randomly down, that is nothing live down there. That must be neutral. There we go. So we get an audible indicator, and the LED changes color as well. So that's quite nice. Yeah, so you can just probe around for live. Quite handy actually. Yeah, especially when you have got high voltage next to low voltage and you don't want to electrocute yourself. Okay, so we've had a look at DC volts, we've had a look at AC volts. I'm very interested in the frequency counter, so let's go to frequency. Let's drop this. Okay. I don't want to hold on here anymore. Let's go to frequency. Okay. Okay. I've got my waveform generator pushing out a 10 kilohertz. Is it 10 kilohertz or 10 hertz? Let me just see. 10 hertz frequency. So I'm just going to clip that on there and clip this on here. Okay, so that is spot on, and if I 11, 12, 1401, 13, 12, let me go one more. Let me go 2 decimal places down. And 11.97, 11.96, 95, 94. It's a bit slow, but it is picking up. It is picking up the changes at 2 decimal places. Okay, let me go up to the max and see what it is actually. So that's 21 kilohertz. So I need to go up. Oh, here we go. Okay. 1 megahertz. 1.021. I should have cleared out those decimals. 2.022, 3. So let's crank this up. 11 megahertz, 13, 16, 18, 19, 20. So it's already past the 10 in the manual. 21. 21.02, and I'm on 21.02, so that is actually spot on. 23, 02, 24, 25. So is it a 50 limit? No, it's died. It has died at 30, no, 29, doesn't like 28. It doesn't like that. 26 megahertz. Yeah, 26 megahertz is its limit. So that's, well, 16 more than the manual, if I remember correctly. Or did it say 20? No, 1 hertz to 10. So it's gone 16 over the advertised. Okay, let's see how the Fluke does here. Can I get to... I don't think the Fluke's got the same kind of range at all. Just struggle to get everything clamped together. There we go. Okay. So we're on 26 megahertz and Fluke is not reading anything. So let me just drop this way down. Okay, so we're on naught. Okay, so 1 kilohertz, 2 kilohertz, 3, 4, 5. So the Fluke is spot on to 3 decimal places. 6, 7, 8, 9, 10, 11. Okay. I don't know what the max is of the Fluke, so let's just crank this up and see where it cuts out. Ah, 100 kilohertz must be. So 99. So the Fluke can't handle over 100 kilohertz. So that's quite impressive, the frequency range. Yeah, that's very nice, especially if you into radio and HF. Yeah, 40 meters, 20 meters and 40 meters if you make building your own equipment. Very useful. Okay. Likewise, on my oscilloscope, the calibration, let's just put this on hold. Why is it on 50 hertz? It's picking up AC from somewhere. Picking up AC from somewhere. getting a reading. Why am I not getting a reading? Let's give you a power cycle. I am not getting a reading. Let's switch and see why you're being difficult. Okay, well, let us power cycle my scope. Okay, that's not going to work. There we go. Okay, let's try again. And I am not getting a reading. Okay, let's see what's going on here. Try with the Fluke. 1 kilohertz is what I would expect. Okay, so why are we not getting a 1 kilohertz reading here? It's got 50 hertz. No, it's refusing to pick up that. It's very interesting because I tried earlier and it was picking it up. So not sure what's happening there. Yeah, it is definitely refusing to pick up the calibration signal from my scope, whereas Fluke is not having an issue at all. 1 kilohertz on the dot. Okay. Let us look for some other components to test. Okay, let's go into diode mode and play around with the LED. Yep. But it's a continuity diode mode. So it beeps on continuity, but it doesn't beep when it goes through the diode. Okay, that's reverse polarity, so that's not going to work. But here, So it gives you the voltage across the diode, but it doesn't beep for continuity. Interesting. Okay, so 1.70. Oh, I'm not in frame. Not in frame. .709 across the diode. Okay, 1.709. Let me just put that on hold and get that reading. Now you're gonna hold something rubbish, aren't you? Okay. Okay, there we go. So let's hold that. Diode. Oh, it's capacitance diode. That's the wrong lead. Okay. So that is working. 1.646. Ooh. That is quite a discrepancy, the voltage across LED. Let's just check that this is doing its job. Yep, nothing there going the other way. So 1.645 volts across using the Fluke. 1.71 using the pen. Now that's quite a big discrepancy. Okay, so that's diode. Okay, let's look for resistance. Let's look for a resistor. Do I have any resistors lying around right here? Probably not. Probably not. Okay, let's just cheat. Okay. A roll of wire is a resistor. That's the worst hack ever. Okay. Ashamed. Absolutely ashamed. So this now doesn't have a resistance mode, so we have to put you into auto. Okay, and so that goes into continuity. And okay, but can you give me a resistance reading? No, it's all over the place. 1.8. Let's put it on hold. Okay, so the hold actually blocks it from taking a reading. Oh, 0.5. It's quite a long roll of wire. I'd expect a few ohms of resistance. 0.5. It's up to 10. No. Help if you can. Okay, so 0.5. Okay, let's see what Fluke says this roll of wire is. 0.6, also kind of all over the place, but I don't know how much. No, 0.6. Yeah, we need something with more resistance. Okay, let's see what else we've got lying around. Okay, it's a tiny surface mount. This may just ping across the room. I've got no idea what the value is. 0.1 ohm. 0.1 ohm. I think this is actually a 0 ohm resistor. 0.1. I think it's a 0. Let me just have a look quickly. Oh, my eyes aren't good enough. But it does, yeah, it's got a 0 one. So that is, yeah, an absolutely excellent choice. Continuity, 0 ohms. So it's actually doing a better job than the Fluke, because I mean that is a 0 ohm resistor. Okay, let's go back to the Fluke. .1 ohm. If I got to continuity here, it's going to see it as no resistance. 0.1. Very interesting. Okay. Okay. What haven't we tried? Capacitor. Okay. Here's a better one. Okay. I don't know. It starts with a 2. That's what I can see with the naked eye. 25.1 ohm. So if I push hold, does it take a reading? No. So that hold is only once you've taken the reading, then you've got to kind of reach and push hold. That's not brilliant. Okay, 25.1 ohm. Okay, stick you over there, and let's see what Mr. Fluke says. Oops, ping. Let's get both on at the same time. 24.9. You're all over the place, but I don't have connection. There. No. Still not. 24.9 ohms versus 25.1 on the pen. Okay, I've seen another gentleman do a comparison like this, much better job than I'm doing, and his was much closer. He was also using comparing to a Fluke 26. Why is that reading going up? 24.9. Yeah, so it might vary from model to model, or it may be that buying from Wish, that I've got one that's fallen out of specification. It's not accurate enough, and hence it's getting sold on Wish. Maybe just a theory. Okay, let's see what capacitance looks like. Too small, and I'm too shaky. Okay, 18.29 nanofarad. How on earth am I going to get it to hold that value? I'm not. Am I? No. I'm never going to get it to hold that value. There we go. Okay, I did. Okay. 18.29 nano. And what does Fluke say? No, I should have changed to Fluke's own leads. I think I'm going to change now quickly. Even though those are good leads, can't really test Fluke without using its own leads. Okay. And we want you here, and capacitance, and we want to get in on this tiny little thing. 18. Okay, that's interesting. So the Fluke doesn't have decimal places because it's auto-ranging. Now let me see if I manual range what it does. Whoops, ping. Range, there we go. Where's that cap gone? There you are. Oh, I've gone into microfarads. That's no good. Okay, range, micro, nano, micro. So it's only got the 1 nano. Come on, lie down. Oh. Come on. 18. With no decimal points. Now, in all fairness, you don't really need those decimals. I mean, 18 nano is enough in 99.9% of circumstances. But it is interesting that a 15-pound multimeter, they have designed it to give 2 decimal places, and that the Fluke doesn't. Yeah, interesting. So we've done DC voltage, we've done AC voltage, we've done frequency, we've done resistance, and we've done capacitance. So I don't think there's much more to show in here. My office is getting quite toasty. 30 degrees, it could easily be. So DC volts we've done, AC volts we've done, capacitance we've done, diode and continuity we've done. Does the Fluke have temperature? I wouldn't have thought so. Yeah, that doesn't have temperature. And frequency we've done. Yeah. So all in all, it's not bad. It's pretty accurate. This auto mode is really nice for when you poking around. The only thing that would have made this really useful would have been a logic, if they had built a logic probe in. They could have, used the built-in speaker. They could have used the LED or anything to indicate, the high or low signal, logic signal, because that would have been really nice and made this extra useful. If you could probe around a digital circuit and see which pins are high and low, and follow the logic. So that is the KKMoon KKM100. Not bad for £15. Does a sterling job. It looks quite nice. I must say that the twist test or the bend test, there's not a creak. This thing, it may be made of plastic, but it is really built. It is built really well. The only flimsy bit is this clip for putting in your shirt pocket. But otherwise, yeah, it's got a nice clear screen. Good good audible tone. It's a bit slow, but it's £15. What can you expect? Yeah, so there you have it, folks. A £15 Wish multimeter, all in one in a pen, versus a I don't know what these Fluke 117s are currently going for. But yeah, comparison to see how accurate this was, and my conclusion is for the hobbyist, this is perfectly adequate and is really nice and useful. So yeah. Thanks for joining me today. I'll see you guys next time. Cheers and